Have you ever wondered how electricity is generated, or how a simple push of a button can create a powerful force to drive machinery? The answer to these questions lies in a fundamental principle of electromagnetism known as Faraday's law of induction. Named after the brilliant scientist Michael Faraday, this law explains how a changing magnetic field can induce what we call an electromotive force, or EMF, in a conductor. This phenomenon, known as electromagnetic induction, forms the cornerstone of many crucial electrical devices, including the transformers, generators, and motors that power our world. Let's dive into the formula that encapsulates this law. Faraday's law states that the electromotive force induced in a closed loop equals the negative rate of change of the magnetic flux passing through that loop. In simpler terms, the faster the magnetic field changes, the greater the current it induces. In mathematical terms, we express it as epsilon equals negative n times the change in magnetic flux over change in time. Here, epsilon represents the induced EMF in volts, n stands for the number of turns in the coil, and the change in magnetic flux is represented by dph dt. Now you might be wondering, in which direction does this induced current flow? This is where Lenz's law steps in. According to Lenz's law, the induced current always flows in a direction that opposes the change in magnetic flux that caused it in the first place. Faraday's law of induction is not just a theoretical concept, it has practical applications that impact our daily lives. Transformers, for instance, use this principle to transfer electrical energy from one circuit to another by changing the voltage and current levels. Generators employ Faraday's law to convert mechanical energy into electrical energy, and motors, they turn electrical energy back into mechanical energy. Again, all thanks to Faraday's law of induction. Consider the generator that powers your home. When a coil of wire rotates within a magnetic field, the magnetic flux through the coil changes, inducing an electromotive force. This is the electricity that lights up your home and powers your devices. Or take the humble transformer. It has two coils of wire wrapped around a common core. When an alternating current flows through the primary coil, it induces an electromotive force in the secondary coil, effectively changing the voltage and current levels of the AC power. And what about an electric motor? It has a coil of wire placed within a magnetic field. When an electromotive force is applied to the coil, it generates a current that interacts with the magnetic field, causing the coil to rotate. This is what powers the motor in your refrigerator, the fan that cools your room, and countless other devices. In summary, Faraday's law of induction is a fundamental principle of electromagnetism that explains how a changing magnetic field can induce an electromotive force. It is quantified by the formula epsilon equals negative n times the change in magnetic flux over change in time. Its applications are widespread and varied, powering everything from generators to motors. So, the next time you flick a switch or push a button, remember that you're witnessing Faraday's law in action.